Hi everyone, Assalamualaikum. In this video, we will continue evaluating inverse trigonometric functions. Okay. Alright, we're still under the second topic, which is evaluating inverse trigonometric function using triangle method. Under chapter 1, inverse trigonometric function. Right? Before we go further, now we look at how to evaluate inverse trigonometric function using calculator. Okay. Alright, how to evaluate inverse cos half using calculator? Okay. Alright, from the calculator here, okay, to evaluate inverse cos half, first we press shift, okay, and then cos, okay, shift cos for inverse cos, and then bracket, and then 1 here, over for here, and then 2 over 2 here, and then we close the bracket. Alright. Okay, after that we press equal here, then the answer equals to 1.04719 if we use mode radian, okay, or we will get 60 if we use mode degree, okay, or we have pi over 3 radian, right? Right, this is the final answer. Okay, if you use symbollab.com. Arch cos here means inverse cos. Okay, so this is the final answer. Okay, this is using calculator. This is using symbollab.com. Right? Alright, now how to evaluate inverse sine 1 over sec 2? Okay, so first we press shift and then sine. Shift sine means inverse sine. And then we open bracket. Okay. And then 1. Okay. And then over. Okay. Sec 2. Okay. And then we close bracket. Right. After that we press equal sign. And then the answer, if we set in mode radian, okay, so we will get 0.7853 something, okay, or if we set in mode degree, okay, we will get 45 degree, okay, or pi over 4 radian, okay. Alright, if we use symbollab.com, arc sine means inverse sine, and then 1 over sec 2, so this is the final answer, okay. Right. How to evaluate inverse tangent 1 over sec 3? Okay. First, we press shift tangent for inverse tangent, and then open bracket 1, and then over third, and then 3. Okay. Then equal to. Okay, this is the final answer. Okay. This is in mode radian, this is in mode degree. Okay. Or we can use symbollab.com. Arch tan means inverse tangent, and then 1 over sec 3 equals to pi over 6 or 0.52359 or 30 degrees. Right? This is how you calculate inverse trigonometric function using calculator. Right? Right. How to evaluate inverse reciprocal trigonometric function using calculator? Okay. Let's say we have A inverse sec 2, B inverse cosec sec 2, and C inverse cot sec 3. Okay. So now we want to evaluate the inverse reciprocal trigo function using calculator. Okay. So from here, okay, when we compare from this calculator, okay, there is no button for sec. Okay, we only have sine, cos, and tangent. Okay. And then there is no button for cosec. Okay. And same goes to cot. Okay. There is no button for cot. Okay. So what should we do is, okay, first we can write inverse sec 2 equals to inverse sec 2 over 1. Okay. From here, from the reciprocal trigonometric identity, if we have sine A, so it is equals to 1 over cosec A. Okay. From here, we have sec function here, so we can refer from here. Okay. Cos A equals to 1 over sec A. Okay. Alright. So, from here, we can write inverse sec P over Q equals to inverse cos Q over P. Okay. We just exchange numerator and denominator. How we get this? Okay. Let's say we have inverse sec P over Q. Okay. We write equals to question mark. Okay. So let's say we let y equals to inverse sec P over Q. And then we can move inverse sec here to left hand side. So we get sec y equals to P over Q. Okay. After that, since sec is a reciprocal function for cos, so we can write cos y equals to, we exchange numerator and denominator. Okay, and after that we can write y as a subject and we can move cos to right hand side. So we get inverse cos Q over P. Okay, from here, so we get y here and y here means inverse sec P over Q equals to inverse cos Q over P. Alright. So from this formula, inverse sec 2 over 1. So now our P equals to 2 and Q equals to 1. Equals to inverse cos. We just exchange numerator and denominator. Okay? Equals to inverse cos half. So from here, we can use calculator to find the value of inverse cos half. Okay? Okay, it is similar to example in the previous slide. Alright? Alright, we can check the final answer using symbollab.com. Okay, we can write arch sec 2. Arch sec means inverse sec. Okay, so we press enter, then we get the final answer equals to pi over 3 radian or decimal 1.04719 or 60 degrees. Right? From symbol lab, we can direct use arc sign too. But from calculator, we need to change to inverse cos and then we just exchange the numerator and denominator here. Okay. Alright. And then how to evaluate inverse cosec set 2 using calculator. Okay. Since there is no button cosec on the calculator, so we need to change cosec to reciprocal function sine here. Okay. Okay. So we get this. Okay. Inverse cosec P over Q equals to inverse sine. We just exchange Q over P. How we get this? Okay. Alright. Let's say we have inverse cosec P over Q. We write equals to question mark. Okay. And let's say we write question mark equals to y. Okay. So y equals to inverse cosec P over Q here. Then we can move inverse cosec to the left hand side. So we get ordinary cosec y equals to P over Q. And since cosec is a reciprocal function for sine, so we can write sine y and then we just exchange numerator and denominator. So we get sine y equals to Q over P. Then we can move sine to the right hand side. So we get y equals to inverse sine Q over P. Okay. From here, Here is y and this is also y. So it means that inverse cosec P over Q equals to inverse sine Q over P. Okay, that's why we get this formula. Okay, and then from here we can change to inverse sine. Okay, alright, so we use this formula, so we get inverse sine, we exchange numerator and denominator, so 1 over sec 2. So from here, we can use calculator, okay, to find this value. And this example actually similar to the previous slide, okay, for inverse sine 1 over sec 2, okay. Or we can use symbol lab, okay, we can direct use arc cosec sec 2. Arc cosec means inverse cosec, okay, and then sec 2. And then after we press enter, we will get this answer. Okay, this is in radian, this is in decimal radian, this is in decimal and this is in fraction and radian, this is in degree. Okay. Alright, after that, how to find inverse cot sec 3 using calculator. Okay. Okay, from the reciprocal trigo identity here, cot means the reciprocal function for tangent. Okay. So before that, we can write inverse cot sec 3 over 1. Okay. And then we can use this formula. Inverse cot P over Q equals to inverse tangent P over Q. So we can write inverse tangent, we just exchange numerator and denominator. So we get this. Okay. Alright. Why we say that inverse cot P over Q equals to inverse tangent Q over P. Okay. Okay, let's say we have inverse cot P over Q. Okay, inverse cot P over Q equals to Y. Okay. After that, inverse cot, we move to left hand side. So we get ordinary cot Y equals to P over Q. And then we can write tangent, okay, since tangent and cot are reciprocal function. So we can write tangent Y equals to, we just exchange numerator and denominator here. So we can write Q over P. Okay. And after that, we can write Y as a subject and we can move tangent to the right hand side. So we get inverse tangent and then P over Q. Okay. Alright, from here, we have Y here and Y here. Means that inverse cot P over Q equals to inverse tangent Q over P. Okay. Alright. We also can use symbol lab to find the final answer. Okay. So to solve inverse cot sec 3, okay, we can use arch cot. Arch cot means inverse cot. Okay, and then bracket sec 3. After we press enter, we get this answer in decimal and radian. This is in degree and this is in fraction and radian. Okay, and this example is similar to the previous slide. Okay, so you can check this answer from the previous slide, right? Alright, how to evaluating trigonometric function and their inverse. Okay, now we look at example 1. Without using calculator, evaluate A, cos composite with inverse cos half, B, inverse sine composite with sine pi over 2, and C, inverse tangent composite with ordinary tangent pi over 4. Okay, now we look at the solution. Okay, A, to evaluate this function or this trigonometric function, okay, we can refer from the properties of trigo function here. Okay, from the properties here, every time when we have the same trigo function, one of them is ordinary and one of them is inverse. So the answer equals to x. Okay, so from here we have cos composite with inverse cos half. Okay, we can refer from these properties. Okay, and we can simplify and the answer equals to x. So when we compare, our x now equals to half. So means that the answer equals to half. Alright? And then B. Okay. To evaluate inverse sine composite with sine pi over 2, we can refer from this formula. If we have inverse sine composite with sine x, the answer equals to x. So now, when we compare, our x equals to pi over 4. Okay? So, pi over 2. So, means that the answer equals to pi over 2. Okay? And then C. We have inverse tangent composite with ordinary tangent pi over 4. Right, from this formula, when we have inverse tangent composite with tangent x, the answer equals to x. So means that when we have inverse tangent composite with ordinary tangent pi over 4, the answer equals to pi over 4. Okay, from this example, every time when we have composite function between the same trigo function, one of them is ordinary and one of them is inverse. So the answer, so we can simplify, okay, and we get x, okay, from here, okay. All right, we can also use symbol lab to check the answer, okay. All right, from A, okay, we have cos and then inverse cos. Using symbol lab, we need to use arch cos and then bracket half. After we press enter, so we get this answer, okay, half. Okay, and then B, okay, inverse sine means arch sine and then sine pi over 2. Okay, after we press enter using symbollab.com, the answer equals to pi over 2, or in decimal 1.57079 something, or 90 degrees. Okay, okay, and then C, okay, inverse tangent means arch tangent and then tangent pi over 4. Using symbollab.com, the answer equals to pi over 4, or in decimal 0.78539 something, or in degrees 45 degrees. Alright? Okay, that's how we evaluate trigo function and their inverse. Okay, we can straight away simplify using the properties of inverse trigo function, and this formula we have been discussed in the previous video, right? Coming up next, examples involving evaluating and simplifying composite inverse trigo function using triangle method. Okay, if you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.